Hi, I'm Troy Miles, and welcome to Beginning Ionic Hybrid Application Development by Pact Publishing. I've been a software developer for over 35 years. I've built applications for a wide variety of systems. I've also been a speaker on all aspects of software development. I picked up Ionic almost 2 years ago, and I really enjoy working with it. I've been building websites with JavaScript for nearly 10 years, using AngularJS for 3, and I've also built mobile apps using both native tools and PhoneGap. We'll start off our course by getting introduced to the framework and installing the most important components, VirtualBox and Vagrant, to get us up and running. We'll familiarize ourselves with Ionic commands, templates, themes, and headers so we get a head start. We will then create an Ionic list, render data to it, and take a look at creating services to manage our data efficiently in the sections that follow. Also, we'll add different sophisticated elements such as infinite scroll, pull to refresh, and enhance the user experience by adding HTML and CSS elements to our app and by persisting user data. Finally, we'll talk about deploying our app to an emulator for testing purposes and discuss Cordova plugins that will add more functionality to our app. To work your way through the course, you should have a fair knowledge and experience of working with AngularJS, CSS, and HTML. Familiarity with JavaScript and Cordova would be an added advantage, but isn't a necessity. Welcome aboard, and let's get started.
Ionic supports two mobile platforms, iOS and Android. Since Android and its tools are free, we will focus on building for it, but keep in mind that everything we build for Android will also work on iOS. To begin, we need to download VirtualBox. We navigate to its website at www.virtualbox.org/wiki/downloads. Then find the version to match your operating system and click the link. I've already done this step, so I won't show it here, but once the download is complete, double-click the package and follow the on-screen instructions to install. Next, we need to install Vagrant. Vagrant is an application which creates and configures lightweight and portable development environments. We navigate to its website at www.vagrantup.com/downloads.html. Again, find the version to match your operating system and click the link to begin the download. Once the download has completed, double-click the package and follow the on-screen instructions to install. The final download is on my GitHub repo. Navigate to github.com/rockencoder, that's ROCKNCODER /Ionic-box. In the lower right-hand side of the page, click the Download Zip button. This will download a file, ionicboxmaster.zip. Once the download is complete, uncompress the zip file to a directory named ionic-box-master. We will do all of our host computer's side work from this directory. Open Terminal, or if you are on Windows, a command prompt, and cd into the Ionic Box master directory. Next, enter the command vagrantup. This command tells Vagrant to build a virtual machine containing our development environment. It will take some time for the download to complete depending on your internet connection. I am going to pause the video until the download has completed. Now that the download has completed, execute the command vagrant ssh. This will connect us to the virtual machine or VM holding our development environment. To exit the virtual machine, type exit, and you will be returned to your host machine. In the last video, we installed Ionic via the Ionic box. The box creates a virtual machine, also known as a VM, with all of our development tools on it. One important thing that we have not mentioned yet is that Ionic requires an active internet connection. Many of its commands look for the data that they require online. Ionic is not fully functional without the internet. From our host machine's Ionic box master directory, we run the vagrant SSH command to enter our development VM. Next, we change directories to move to our work directory. Ionic is driven from the command line. There are over 24 commands, but luckily we only need to know a few to get started. Each of the commands follows the word Ionic. Probably the most important one is for help. So you type Ionic space help, enter. The help command shows a wealth of information. The first useful bit is its version number. At the time of recording, it is version 1.5. Next comes a list of commands, the first of which is the start command. It is used to create a new Ionic application. The serve command allows you to use your web browser to develop and test your application quickly. The platform command allows you to target one or both of the two supported platforms, Android and iOS. The run and emulate commands are very similar, except that one deploys code to an actual device and the other deploys to a simulated device. Both the Android emulator and the iOS simulator are supported. Both the run and emulate commands build the app before deploying. The build command builds your app without deploying it. The plugin command adds a new Cordova plugin to your application. The resources command automatically creates icon and splash screen resources for your application in all of the myriad of different device sizes. The templates command displays a list and description of all the available Ionic starter templates. Type Ionic templates. The current list is blank, complex list, maps, Salesforce, side menu, tabs, and test. The list of templates occasionally grows, so you'll want to check again every now and then to see if there are any new ones. If you want to know more about any commands, just enter Ionic help and the name of the command you would like to know more about. So to find out more about the resources command, type Ionic help resources, and Ionic will give you more information about it. Let's create an Ionic app. In the virtual machine, return to the Ionic projects directory, then enter Ionic start blank-demo blank. Ionic creates a directory named blank-demo. Ionic will download the template, unzip it, and use it to prepare our new app. Once our app is ready, Ionic will display a few helpful tips. It may also ask if you would like to use an ionic.io account. If it does, simply type in for no. cd blank demo. This puts us in the applications directory. All of Ionic's project commands require us to be here. Then we type Ionic serve. This will make our app available via a local web server on the VM. If you are prompted to choose a port address, simply type 1 to choose the first port. With the web server running, open a web browser on the host machine. I am going to use Chrome since it has mobile emulation built in. Navigate to http://localhost:8100. And here is our app. So if we press Option-Command-I on the Mac or Control-Shift-I on Windows, it will bring up the Chrome Developer Tools. The second icon in the upper left-hand corner, next to the magnifying glass, toggles mobile emulation. If it is not blue, click it to activate the mobile emulator. Above the web page layout is the device list. Click it to see the list of devices. For this video series, I will be using the Chrome Nexus 4 emulator. Select it and click the refresh button to reload the page. The blank template is a bit boring, so let's check out the tab template. We go back to the VM, type Q to quit the web server, cd Ionic-projects. This time we enter Ionic Start Tab Demos tabs. Once Ionic has finished creating our new app, cd tab-demo, Ionic serve, return to the web browser on the host machine and refresh the page. With the emulator set for a Nexus 4, we see the tabs up on top, Android style. If we change to an iPhone 4 and refresh the page, we see the tabs iOS style at the bottom. Again, we go back to the VM, type Q to quit the server, return to the Ionic project directory, and enter Ionic Start Coffee side menu. Once Ionic has finished creating our new app, cd Coffee, Ionic serve, and return to the web browser on the host machine and refresh the page. Now we see the side menu demo app. Vagrant creates a shadow directory on our host machine of the Ionic projects directory of the virtual machine. We can edit files in this directory. I will be using WebStorm, but any text editor will do. And then into the www directory. And finally into the templates directory. Open menu.html. We will only make a small change to the theme for now by changing all occurrences of bar stable to bar energize. This instantly causes our app to change. This is because the Ionic serve command also watches for changes to our files, and if it detects a change, it will reload the app. This way we get instant feedback on any change we make. And when we return to the browser, there is our app. Congratulations! We have covered a lot in this section. We looked at how our entire course will go. Then we installed Ionic, worked with some of the Ionic commands, and explored different available built-in Ionic templates. In the next section, we'll take a look at programming in Ionic. Hi, and welcome back to Beginning Ionic Hybrid Application Development. In our last section, we got introduced to Ionic, some of its commands and features. This is the second section, Programming Ionic. In this section, we will take a look at Ionic app structure, routing, adding menu items to our app, creating controllers, and the Ionic list. This is video 2.1, Ionic app structure. In this video, we will discuss the app structure and MVC concepts. Let's see what an Ionic app looks like. From the host machine, open Finder or Explorer if you are on Windows, and navigate to the Ionic box master directory. Navigate into Ionic projects, then the last app we built, Coffee. An Ionic app at the root has a few directories, a project file, and a JSON file. The first directory is hooks. It holds code which is executed at key steps in the build process. Ionic uses the after prepare hook to decorate the HTML markup with classes indicating which platform the code is running on. The next directory is plugins. Plugins are used by the underlying Cordova platform to talk to the native device. Out of the box, Ionic includes 5 plugins: Console, Device, Splash Screen, Whitelist, and Keyboard. The Console plugin is a simple tool which makes the browser's console object available if it doesn't exist and forwards its output so it is visible to the developer, usually via an IDE. The device plugin makes device-related information available to your application. The splash screen gives the developer a customized screen which is displayed while the application is loaded. If you don't add a custom image, it will be a generic one. Without the whitelist plugin, an Ionic app is restricted from accessing locations outside of the device. The keyboard plugin was created by the team at Ionic. It makes interacting with the keyboard easier for developers and more fluid for users. It also provides a solution to the dreaded issue which haunts a lot of Cordova apps, the keyboard pushing the text input off of the screen. The SCSS directory is for Ionic SAS. The individual files are not actually kept here, but there is a placeholder file which gathers all of the SAS files. The platform directory doesn't exist until you add one or more platforms to your project. Once you do, you'll see either an Android or iOS or both subdirectories here. These projects can be opened in Android Studio or Xcode. The final and most important folder is www. This is your application. The contents of the www directory should look familiar to anyone who has done any web development. Your application runs inside either a UI web view on iOS or a web view on Android, which is created by Cordova. One of the most important things to understand is that your app files are stored on the device. They are not normally fetched from a remote server. Typically, there are 5 folders here. A CSS folder which holds an empty style.css file. This file is created for you to place your styles by Ionic. There is an img directory for any images your app may need, the JS directory for all of your JavaScript files. The lib directory holds the components of Ionic and Angular. I usually stick any other library my app needs here as well, so libraries like Lodash and jQuery would go into this directory. And if you choose any template other than blank, there may be a template directory here as well. It holds all of your app's views. In the root of the www directory is the index.html file. This is the default place where your app kicks off. It is possible to change this to some other file if desired. In the next video, we'll talk about routing.
In order to start making this app our own, we need to understand how routing works in an Ionic app. Routing is the detection of specific URLs and the code which binds it. It may seem strange to talk about routing in a mobile app, but routes exist in Ionic even though there is no visible URL bar. In fact, routing is a great way to build an app because it gives you a single place to see all the major sections of your app. In the Angular world, there are 2 popular routers. The first is the router which ships with Angular, NGRoute. NGRoute is easy to use but lacks a lot of important features which help when building larger apps like nested views and multiple view names. For that reason, the Ionic team chose the second most popular Angular router, UI Router. UI Router is an open source project developed by a team not associated with the Angular team. It has nested views and it also defines the state for every route. You can pretty much use any editor you'd like with Ionic. I know devs using Sublime Text, Brackets, and Atom. For JavaScript apps, I prefer WebStorm, and I will be using it for the rest of this series. The router for our app is in a file, app.js, located in our JS directory. Let's open it. If we scroll to the bottom of the file, we see where the router is configured. UI Router is state-based, so we can see each of the different states being defined. Each state consists of a name, a URL, and at least one view. Let's add a state to show listings for nearby coffee houses. On the last line of the router, we add the following code. Please note, we have purposely not defined a controller. The last line of the router is the otherwise route. This is the route followed when there is no matching route. In a website, you might have a 404 page, but this is not recommended for a mobile app since it would be confusing for your users. Instead, we should send the app to
a known page. In our case, we'll make it the listings page, which we just defined. With our route defined, we need to define a view for the listings page. Create a new file named listings.html in the templates directory. Add the following markup to it. Let's try our new route out by entering it in the URL bar. And we navigate to the page we just created. Now watch what happens if we type a bad route in the URL bar. Again, we return to the listings page since it is our otherwise route. Now we need to give our users a way to access the listings page from our app's menu. Adding items to the menu is easy. Let's open the file menu.html in the templates directory. In the upper part of the markup is the Ion side menu content. It defines what is on the screen when the side menu is closed. Included in it is the Ion nav view. This is where views in the template are injected onto the page. In the lower part of the file is Ion side menu. This directive defines the items on the menu. The tag Ion item is an Ionic Angular directive which defines a menu item. By including an href attribute, Ion item will automatically nest an anchor tag that links to the specified location. Let's add our entry. Move to below the last Ion item playlist and add the following markup. This markup is fairly straightforward. We are adding a new Ionic menu item for listings. The attribute menu close indicates that when this link is clicked, the side menu will close. The value in the href represents the location the app will navigate to when clicked. Let's try it in the browser. Let's navigate to the search page, then click the listings menu item, and we see our new page. Currently, we are using an href to specify the destination. But didn't I say that UI router was state-based? We can use a state instead of a URL by using a UI sref instead of an href. Change href equals app/listings to UI sref equals app.listings. Our app behaves exactly the same, so why use a state instead of a URL? Well, imagine your app is a bit more complicated. If you use a URL and that URL needs to change, you will have to search through your code for every place where that URL is and change it. If you use a state, you only need to change the URL once in the router. So now we have a listings view and a menu item which allows us to navigate to it. But we don't have any way to control the behavior of the view. This is the job of the controller. Let's add one. First, we need to navigate to the router and add a controller to our route. Open app.js and scroll to the bottom of the file. The app.listing state should be the last one. On the line templates listings.html, we add a comma, a new line, and controller:"listings controller." Please note the capitalizations. Remember, JavaScript is case sensitive. We return to the controller.js file, scroll down to the bottom of the file, Locate the last line which defines the playlist controller. Before the final semicolon, we add our listings controller. Inside the controller, let's create a test message just to make sure everything is functioning correctly. We add a $scope dot message equals hello Ionic and a semicolon. Next, we go to the listings.html file. We replace the h1 tag with a new line, double open curly braces, message, double closing curly braces. In Angular, this is referred to as string interpolation. We save our changes and return to the browser. And there is our message, so our controller is functioning correctly. In this video, we will render an Ionic list to our view. In order to create a list, we must first modify the listings controller. We need to delete the test message we previously created, then create some sample data for our list, and finally, we will render the list to the view. We begin by opening the controller.js file and scrolling to the end. There, we should see our listings controller. We delete the previously added scope.message. Next, we add a new scope property, listings, which is an array. In it, we create an array of objects, each of which will have a single property called business name. We cut and paste several of these objects, giving them names like alpha, beta, gamma, and so forth. Next, we go to the listings.html file. Here is where the magic happens. We replace the markup inside of the Ion content with an Ion list. Inside of it, we add Ion item. The Ion item gets an Angular ng repeat directive. We will iterate over the listings, each of which will call an item. So we write the directive like this: item in listings. The only property we have is the business name, so let's display it. Now, if we've typed everything correctly, we should have our rendered list. Let's go back to the Chrome browser, and there is our rendered Ionic list. Excellent. Great, that brings us to the end of section 2. In this section, we discussed our Ionic app structure, learned what routing is, and added items to the menu. We also created controllers and an Ionic list. In the next section, we'll take a look at implementing services in Ajax in our app. Hi, and welcome back to Beginning Ionic Hybrid Application Development. In our last section, we got into the basics of our app structure and added menu items to our app. This is the third section, Services in Ajax. In this section, we'll take a look at Angular services, Ajax calls, calling a service from a controller, and adding infinite scroll and refresh elements. This is video 3.1, Creating an Angular Service. In this video, we will explain what an Angular service is and how to create one. In AngularJS, it is considered a best practice to implement data access from a service rather than in a controller. So we'll first move our sample data into a service, then replace it with a real Ajax call in the next video. Return to the app.js file and add a service, named listing service, to the end of the file before the final semicolon. Inside of the service, return an object which holds the service's API. The API consists of one method, getListings, which will return an array of business listings, For now, we'll use the same mock data that we used in the controller. In the controller.js file, delete the sample data add the listing service as a resource, and make a call to getListings method to get the listings. If we look at the browser now, we'll see the same data listed as before. Before we can make a call to a third-party web service, we'll need to install a Chrome extension, allow control, allow origin. Normally, from the browser, we would not be able to access a web service outside of our app's domain. Allow control, allow origin will allow us to do that. Go to https://chrome.google.com/webstore. Below the search box on the left-hand side, click on the Extension tabs, and in the Categories drop-down, choose Developer Tools. Then in the search box type allow-control-allow-origin and press Enter. It should be the first entry in the list of applications found. Click the blue Add to Chrome button and accept the app's permission. Once installed, be sure to activate by clicking it. It will enable cross-origin resource sharing. The button should be colored green. In the next video, we'll talk about making an Ajax call. In order to find actual coffee shops near us, we will use yp.com's local search API. This service is free for developers and allows your app to make up to 50,000 calls a day to it. To sign up, go to publisher.yp.com. After you sign up and register your application, they will give you an API key. Your app must include this key when you make calls to the API. You must get your own key. I cannot supply one to you. Once you have your API key, return to the file app.js. We will need to make some changes to the listings service. We will need the $HTTP and $Q resources and our API key. I am passing mine in as a resource, but you can create your API key as a string constant inside the service. Then add the API's base address. It's pretty long, so let's be sure to type carefully. http://pubapi.yp.com/search-api/ search/dev-api/ search ? Format equals JSON ampersand, sort equals distance ampersand, search LOC equals. Whew, that was pretty long. We'll also need to set a few other variables for the service to use. First, we need to tell the web service how many listings we want with each call, so we set listings per page to 20. We will hardcode the location to 90012, which is an area near downtown Los Angeles. And finally, we set the search radius to 5 for 5 miles. Next, below the return statement, we are going to add a function, filter out metadata. It takes one parameter, data. This method skips past the metadata that comes from the web service. We need to completely revamp the getListings method. First, we need variables for the dynamically generated URL and the deferred object that this method returns. Then we check to see if a page number was passed. If not, we set it to 0 so we can receive the first page worth of listings. Then we generate the URL. We need to mix a few more fields into it. Finally, we make a call to the service using the $HTTP's get method. If the call is successful, we use the filter out metadata method. If listings were good, we resolve the deferred object by calling resolve and passing along the listings. If we get any errors, we reject the deferred object. Now that we are finally receiving real search results, we'll have to modify our controller to properly handle it. Currently, we simply make the call to the listing service's getListings method and assign the results to the listing property of our scope object, but that won't work anymore since a promise is returned, not listings. So instead, we put the following. We initially set listings to an empty array. Then we make the call to the getListings method, and in the then clause of the promise, we handle the success method by assigning the list, which is passed to us, to the listings property of the scope object. And now when we look at our app, voila, we see real coffee shop listings. It is nice to finally have some actual coffee shops displayed. But what if our user doesn't find one that they like in the first set of listings returned? It would be nice if we could give the user more listings, and we can using a technique called infinite scrolling. Return to the controller.js file and modify it as follows. We added a couple of new variables, current page, which shows the current page number, and a flag can show more, which is true as long as there are more listings which can be fetched. We also add a new scope method, loadMore, which is called by the infinite scroll element when it is time to get some more listings. The final line of the method, scope.broadcast, lets the infinite scroll element know that the update is complete. We also need to add the infinite scroll element to our view. Go to the listings.html file and add the new element just before the ion list closing tag. The infinite scroll can be read as, if we can show more listings and we are within 10% of the bottom of the page, call the loadMore method. Now, when we go back to our application and we scroll, we can see it fetch more coffee shop listings. Our infinite scroll is working. Currently, we can continuously add more listings, but we have no way to start over and refresh the list from the beginning. So let's add pull to refresh to our app. We'll begin by adding the refresher element to the view. Open the listings.html file, insert the cursor on the line below the opening ion list tag, and add the ion refresher tag. That's all we need on this page. Now return to the controller.js file. We need to make a few quick changes to the controller. First, we wrap the initial call to get listings in a method called init. Then we add a new scope method, refresh. This is a method indicated in the ion refresher element. We call broadcast with scroll.refreshComplete to tell Ionic that the refresh has been handled. Keep in mind that this method is called every time the user pulls down on the list and when the controller's code is first executed. Now we return to the browser, Hold down and watch as the app refreshes the list. Congratulations, we have now completed Section 3. In this section, we saw how to make an Ajax request for data. In particular, we created an Angular service and made an Ajax call. We also added dynamic elements like infinite scroll and pull to refresh. In the next section, we will look at Ionic components and persistence.
Hi, and welcome back to Beginning Ionic Hybrid Application Development. In our last section, we got into the basics of Angular services, making Ajax calls, and adding infinite scroll and refresh elements. In this section, we'll take a look at the CSS and JavaScript components, adding components to a view, creating and updating an Angular value object, and saving and restoring the value object to local storage. This is video 4.1, CSS and JavaScript components. In this video, we'll look at CSS and JavaScript components. Ionic has two basic types of components, CSS and JavaScript. CSS components don't need any user code in order to function. In most cases, you simply add the HTML tag to your page, set its attributes, and let the magic happen. JavaScript components require you to write some code, usually in the controller, for the magic to happen. The best place to learn about both types of components is the ionicframework.com. Let's go there and see some components firsthand. From the site's homepage, click Docs in the upper right-hand corner, then click CSS Components near the middle of the page. Before we begin our tour, you should know that most CSS components have two styles. The first is as a class added to an HTML element, usually a div tag. The second is as an AngularJS directive, usually an element position. The documentation shows both styles of components. Let's begin by taking a quick look at the header component. A header is one of three major sections of a page. It sits at the top of the page above the other components, the content and the footer. Like most CSS components, the header can be given one of Ionic's 9 theme options. It can also have a subheader added to it. While header and footers are fixed to the top and bottom of the page respectively, the content is in the middle and scrolls vertically to accommodate all of the markup. Ionic supplies a wide variety of buttons. The basic button is just wide enough to wrap its enclosed text. The block button will stretch to fill all of its parent container's width. The full width block button is very similar to the block button, except its width stretched all the way to the edge with no horizontal padding spacing it out. We have already seen an Ionic list and list items, but we haven't seen the list divider yet. List dividers give a bit of separation between the items in the list. List buttons allow you to place a clickable icon on either the left or right side of a list item. Cards allow you to create a UI similar to that of Google Now. The individual cards can have headers, footers, thumbnails, and lists. Ionic has several different styles of text input, all of which support some kind of placeholder text. The placeholder text can be inline, to the left or right of, or even on top of the text input. The Ionic toggle is one of a few different ways to wire up a Boolean value. There are also checkboxes and radio buttons. The range allows the user to slide their finger between two different values. JavaScript components usually require some code to be added to the controller in order to function. Let's see how we would add an action sheet component. Let's see how we would add the action sheet component to our playlist page. First, we go to the action sheet documentation page. Under the usage section, it shows some sample code. Copy this code and paste it into our playlist control. Then we add the two specified resources, Ionic Action Sheet and Timeout. In the playlist view, we add code to trigger the action sheet. Then we go to the browser, navigate to the playlist page, and click on any of the list items, and up pops our action sheet. It will look slightly different depending on which device type it is running, Android or iOS. Most of the other JavaScript components are used similarly. Most will have some sample code which we can use to get our code up and running. In the next video, we will talk about adding components to a view. Currently, we have some hard-coded data in our listing service. It would be nice if that data could be changed by the user. First, we will change the no longer relevant playlist page into a settings page. Then we will add Ionic components to allow us to set the values for the zip code, search radius, and number of listings per page. Open the page playlist.html. Replace the markup between the opening and closing Ion list with the following. We add an Ion range for the search radius. We add a select for the listings per page. We add a simple text box for the zip code. And finally, just for debugging purposes, we add a little bit of diagnostics towards the end. Next, return to the controllers.js and replace all of the code in the playlist control and finally, for neatness sake, open the file menu.html and change playlists to settings. Then we return to the browser and check out our new settings page. We now have a place to allow the user to change values which are formerly hard-coded, but there is no way to move the values from one section of the app to another. This is where AngularJS's value provider comes in. The value provider allows us to both read and write values which may be needed by other parts of the application. In our app, we will seed the value provider with the default values for the different settings properties. If the user modifies those values on the settings page, we will update the value provider. Let's open up the controller.js file and find the playlist controller. First, add the settings object as a resource to the controller. Then update the source code. Note how we update the settings provider if the user updates the settings component, and how we use the current value of the settings object to see the initial values for the settings components. Next, move to the app.js file. After the routes, add the settings provider. We won't use all the values in the settings providers yet, but don't worry, we will use them all. Then move down to the listing service. We need to add the settings provider as a resource here as well. Then we delete all the hard-coded values and replace them in the getListings method with values from the settings object. Then we return to the browser and check out the upgrades to our app. First, we go to the listings page and force a refresh. Note the names we get. Then we go to the settings page and change each of the values. Change the radius to 10. Change listings per page to 30. And change the zip code to 10001, the zip code for New York City. We return to the listings page, force another refresh, and bam! Now we see coffee shops in New York. So now we can set values and use them in the listing service. But once the user leaves the app, the settings are gone when they return.
It would be great if we had a way to preserve the last values the user entered from one run of the app to the next. In a normal web app, we would use HTML5 local storage for this job, and this is what we'll do here as well. It wouldn't be too hard to write all of the code to access HTML5 local storage ourselves, but luckily there is an AngularJS library which makes it dead simple called Angular Local Storage. From the terminal, in the root of our application, run the command bar install angular-local-storage. This will install the library into our app's lib folder. Then open the index.html file and add a script tag. Open the app.js and go to the top of the file. Add local storage module to the modules list. Add local storage service and settings to the run section resources. The run method is somewhat equivalent to a main method in languages like C and Java. It is a place to put code which should run as soon as the system is up. This code checks to see if there is any data in local storage, and if so, it seeds settings with it. Open the file controller.js, find the playlist control, add local storage service as a resource. Inside of the scope watch function, just before the closing curly brace, add. This will update the data in the local storage every time the user makes a change. Start the server back up. Return to the browser. Now we go ahead and modify some values. Make the radius up to 10, the listings to 30, the zip code to 92105. And when we hit refresh, the values remain the same. Likewise, if we go down, take listings to 5, hit refresh again, the values still stay. Now our settings are persisting across sessions. Great, this marks the end of section 4. We have learned about adding CSS and JavaScript components and then adding these components to a view. We also learned how to create an Angular value object and how to save it to local storage. In the next section, we'll talk about deploying our app and using plugins. Hi, welcome back to Beginning Ionic Hybrid Application Development. In our last section, we took a look at CSS and JavaScript components, adding components to a view, creating and updating an Angular value object, and saving and restoring the value object to local storage. This is the 5th section, deploying and plugins. In this section, we will work with platforms, plugins, and then finally, we will wrap up our course. This is video 5.1, adding and removing platforms. In this video, we'll look at how to work with platforms, especially how to add and remove them. Before we talk about adding and removing platforms, let's fix a glaring omission. Our app doesn't display the addresses of the coffee shops. Open the listings.html file and change the ion item tag. Next, open the file config.xml. Before the closing widget tag, add. This code allows the app to make phone calls. The A tag with the tel:phone number as the link tells the phone to launch the dialer. While building our app, it is nice to be able to run from the browser, but in order to install your phone app to an actual phone, you will need to add a platform to it. From the root of your application, run the command Ionic platform add Android. This will add the Android platform to your application. If you are developing on a Mac and have iOS Development Kit installed, you could replace Android with iOS, but our Ionic box only includes Android. If you wish to uninstall the application, that is easy too. Ionic platform remove Android. Remember,
Once you've removed a platform, it is gone, but if you change your mind, it is easy enough to add it back. In the next video, we will talk about working with plugins. Plugins are one of the best things about Ionic. They give us native application features without having to write native code. Ionic sponsors a website, ngcordova.com, whose ngcordova library wraps Cordova plugins with an AngularJS interface. Up to now, the only location information we've had is the zip code, but we are developing an app for a mobile device, so it would be nice if we could get the device's GPS coordinates. There is a plugin available which will do that for us called Cordova-plugin-geolocation. To install the plugin, from the app's root directory type Ionic plugin add Cordova plugin geolocation. Then type Power install ng Cordova. Note the capital C on Cordova. This installs the ng Cordova library. Open index.html and just before the script tag for Cordova.js add then open app.js, add the ng Cordova module, add a reference to use GPS to the run module, add Cordova geolocation to the listing services resources. Next, we're going to place the entirety of the Ajax code into an internal function named doAjax, which accepts one parameter, location. Then we're going to change settings.zipcode to location. Then, just before the return statement, we're going to add the following code. This code checks to see if the user wishes to use the GPS. If so, it gets the location from the GPS before calling doAjax. If not, it just uses the zip code. Now open controllers.js, add a new setting, use GPS to the initialization of scope.data, add use GPS to the $watch function, open the file playlist.html, add the following before the zip code ion item, we restart the Ionic server, go back to the browser, refresh, turn on use GPS, go back to the listings, and there is our listings based upon our current location, which for me is Tustin, California in the USA. So far, we've only ran our app in the browser. Let's deploy it to an Android device. For this to work, you will need a device with developer mode enabled attached to a USB port. For detailed information on how to do this, go to developer.android.com and search for Android hardware devices. With our phone attached, type the following: ADB devices. You should see a list of all Android devices which are attached to your computer. Next, type Ionic platform add Android. This will add the Android platform to your application. Then type Ionic run Android. This will build and deploy your app to the attached Android device. This will take a bit of time. Here's how the deployed app looks on my Nexus 6. It is being projected to my screen, so it seems a bit sluggish. So we turn on the GPS, go to the listings, and here again are my local listings.
At some point, your app or Ionic itself may need to be updated. To update the Ionic CLI, type the following: npm install -g Ionic. Mac and Linux machines will probably need to use the sudo command first. This will take a little bit of time as it goes out and checks to see if there are any updates. If you would like to update any of your app's plugins, simply delete the plugin and then add it back. So if we wanted to delete the Cordova plugin console, we would type Ionic plugin remove Cordova plugin console. That would remove it. And then Ionic plugin add Cordova plugin console. That will add it back and update it in the process. To learn more about Ionic, visit ionicframework.com and also check out my blog, therockncoder.com, which is therockncoder.com. Congratulations, we have now completed the course successfully. In the fifth and final section, we learned how to work with platforms and we deployed our app to an emulator. Then we worked with plugins. In the end, we looked at useful resources and where to go from here. Thank you for watching. We hope to see your app in an app store soon.